Today, cybercriminals are taking advantage of an expanded attack surface to commit malicious activities ranging from hijacking user accounts to making fraudulent purchases. Businesses need solutions that can protect their sites from this increase in fraudulent activity. reCAPTCHA Enterprise is a frictionless fraud detection service that leverages our experience from more than a decade of defending the internet with reCAPTCHA and data for our network of 4 million sites. To learn more about how reCAPTCHA can defend your website or mobile application against fraudulent activity, visit securityweekly.com/reCAPTCHA. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences' next-gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at securityweekly.com/Signal Sciences. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/Synopsys to learn more.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Join us at InfoSec World 2020, June 22nd to 24th, now a fully virtual event. Security Weekly listeners save 15% off the InfoSec World main conference or World Pass. Visit securityweekly.com/ISW 2020. Click the register button to register with our discount code. Layer 8 is going virtual. The conference will still be held on Saturday, June 6th. Security Weekly listeners save $20 on their ticket by visiting layer8conference.com and using the promo code SecurityWeekly before selecting your ticket type. Please consider supporting Layer 8 or one of their partner organizations when purchasing your ticket. Some of the Security Weekly team will be in our own channel on the Layer 8 Discord server, answering questions and possibly doing some contests. Since 2011, Catherine Chambers has been helping to architect Erdeto's security solutions for web, mobile, and embedded systems. She sometimes posts videos for Erdeto on the subject of reverse engineering under the name Cloakware Kate. Prior to joining Erdeto, Catherine worked for many years as a lead programmer in fast-paced startups. Her experience spans the range from coding and assembler to cloud computing. Catherine holds a master's degree in mathematics from Queen's University. Hello, Catherine. Thank you for joining us.
Hello. Thank you for having me.
So we're happy to have you here, and especially to talk about apps on the endpoint. We talk about on the show quite a bit about web security, but mobile apps have some additional security concerns because these are apps that the client has full control over, or if we use a different term, the attacker has full control over. So let's just start off with what are some of those threats, or what are some of those concerns that we should have in mind when we talk about apps as the new endpoint, or the endpoint, the security issues around them?
Sure. I was actually I came into the last few minutes of your previous interview, and I heard John say something about how 60% of their mobile traffic is coming from mobile, and I think that really hits on the trend, right? That mobile apps are the vehicle of choice for interacting with all kinds of important systems, all kinds of high value assets. They're how we as users engage with social networks. They're how we as employees interact with our enterprise networks. I can't think of an application I use on my desktop that doesn't also have a mobile variant. But increasingly, they're how you interact with physical systems. We all know that there are apps you can use to control door locks, but there are also, apps you can use to control medical diagnostic equipment or other commercial equipment like an HVAC system or a turbine. So the point is that mobile apps really are the new endpoint. They are the points of entry into some really high value networks and high value systems. So when we're talking about security, we really need to be careful that we're looking at mobile apps the same way we look at any other system. And you hit on this in your question. when we release a mobile app to the wild, to the App Store, and users are able to download it, we're giving them full access to inspect the app. They can load it in an emulator. They can install it on a jailbroken device. They can use static analysis tools. They can use dynamic analysis tools to figure out what's going on in the app. And it doesn't matter how many security updates we do later on. Anything we expose, and even version 1 of the app is out there for life.
Absolutely. And I think, there's an easy one to say, like, someone reverse engineering the app, finding hard-coded secrets. So here's your API key for your whatever cloud service provider you're using. That's maybe an obvious one, but there's some more subtle things there too. And you mentioned a little bit of the threats, whether they're controlling like industrial systems, HVAC, mentioning too, like healthcare apps, and even too, right now, currently in the news, of course, is all COVID and contract tracing. So there's also potentially a lot of how these apps are collecting data. But I think there's also some aspects of what about apps being reverse engineered and then even repackaged? What have you seen around, what types of threats have you seen around that as well?
Yeah, you touched on a bunch of stuff there, and maybe I'll talk about a few of them if that's okay. Yeah, so there's a bunch of things. There's a bunch of reasons why someone would want to reverse engineer an app, and some of them are simply repackaging the app. Installing malware in it, installing adware in it, taking a perhaps a paid app, repackaging it, making it freely available through a third-party app store, and using it as a vehicle to launch some other sort of attack against users. But there's possibly some other like more subtle things, like you said. So an obvious one is if you've got credentials baked into the app, someone might be interested in trying to get access to those. But maybe people aren't aware that there are some very good dynamic tool sets out there too. So even if your app isn't hard coding values, doesn't have hard coded secrets, you can use these tools to pick up dynamic data as it flows through the app. And that's when you start talking about things like healthcare data or financial data, banking data. If someone's able to install some sort of instrumentation framework in an app and pull data out as it's being used, that can become very valuable. You mentioned on contact tracing apps, which are certainly very topical these days, and it's been a number of years now that I've been hearing that personal healthcare records and personal health information are amongst the most valuable assets that you can buy on the black web, or the dark web rather, and as we're thinking about things like contact tracing apps, I think and other healthcare apps, we really need to be thinking about how are we handling the data as diligently as possible to make sure that none of our users who are trusting us with some very personal information are exposed. I think maybe it's worth exploring that aside from revealing secrets or revealing data as it's moving through the app, there's perhaps another thing to think about, and that is your app itself may be a trade secret. You may have intellectual property that you've implemented in your app. You may have poured long engineering hours into doing something smarter and better than your competitors, and you wouldn't necessarily want someone to be able to figure that out and exploit it or reuse it or copy it without your knowledge. But
so then what does? Sorry, go ahead.
Oh, I was going to say one more thing, because I think when we think about app security, we're often thinking about that, like, what does my app handle? What does my app do? What sensitive or valuable pieces of information does my app handle that an attacker might be interested in? But one of the benefits of working at a company that has reverse engineers and white hat hackers working for us is that you get a chance to talk to them, and you get to understand a little bit more about how a hacker might view an app. And I think, maybe there are some people out there who are, kind of reassured that they don't think their app would be a target because it's not really handling financial data or anything that, might be a target in itself. But one thing maybe to keep in mind is that hackers, kind of step back a little bit and look at the bigger picture. Just like, they might see a webcam and not see it as a web camera, but as compute resources that they could use to create a botnet. A hacker might look at your app not so much as what your app was designed for, but as what they can do with it, right? So they might not be interested in the assets your app has so much as how could they leverage it? Perhaps your app has a really huge install base, and that's what the attacker is interested in. The app may not have a lot going on itself, but if they can get into your app, if they can repackage themselves into your app and then hit your user base, that might be really valuable. Or if your app uses a piece of third-party software, like an open source library, that the attacker already knows how to exploit, the attacker might decide that your app becomes a really valuable target to them just because of that. Just opportunistically, your app may be a valuable target without necessarily having any sort of those high-value secrets that we tend to think of when we think about hacking.
Yeah, I think that's a great way to expand what what a security team, when they're talking with developers about what's the threat model. And the threat model, as you're very well pointed out, it's much more than, well, we don't have financial data, we don't have personal health data, so we're probably fine. We're not going to be targeted. So that's a great point. I did want to start to then turn from here about the different attacks and say, and especially too, you're talking about you have a lot of reverse engineers on your team that you work with that you've done yourself. What does it then start to look like to protect one of these apps? Because reverse engineering takes some time, but once you've done it, then potentially you could just you have full access to compromise the secrets, you have full access to the back end, what have you. So that's, I guess, the long-winded way of saying let's talk about that protection part and what does it look like to actually defend these clients from reverse engineering.
Yeah. So that's a really important point, right? It is probably prohibitively expensive for anybody to make their app impenetrable. This is an unrealistic goal, and I don't think there's enough engineers on the earth to do that, to invest in making app Fort Knox solid. The goal really is to make it unprofitable for hackers to attack you. You want to be sure that it's a preventative measure. You don't want the attacker to spend their time on your app. They want them to look elsewhere. You want them to give up. You want them to feel like attacking your app is just not worth the trouble. That's really the end goal. And that's one of the things that we do with our products is we protect the app, we protect the way the control flow and the data is used and represented to make it really difficult for an attacker to figure out what's going on. So by that way, we slow them down. We make it annoying and irritating for them, and deter them from making your app the target of their attention in the first place.
Yeah, complexity and cost, right? The two things that deter the attacker is the more complex it is, the more money they have to spend to try to reverse engineer it or attack it. Therefore, I'm not a worthy target. Go somewhere else.
Right now. Yeah, that's right. And one of the techniques that we use in our tools, when we protect an app, I think people are familiar with obfuscation tools, things out there that change the control flow and the data flow and the organization of the code to make it difficult for anyone to understand it, or even for automatic tools to sort of lay it out and understand how it's working. But part of what we do at Airdetto is our obfuscation engine, it takes a source of entropy into every run, so that if you were to change even one line of code, even one piece of code, the difference between the first protected version of your app and the second protection version of your app are completely different. So if you were to have a hacking community who was targeting your app and spending their time trying to figure out how to reverse engineer it, and you were to push an update with just like a tiny code change, they would be completely set back to square one. If they were to do a comparison or a differential analysis between the two versions, they wouldn't find anything to start from. So you can, just by sort of having a regular cadence of updating your app, constantly set a hacking community back to square one.
That's a really good point. I think that really speaks to the idea of just what those time costs trade-off are. Because there's the classic example of with Microsoft Patch Tuesday, attackers are just taking the binary that's been updated, reverse engineering, finding out what the security flaw was, sometimes within hours. and have a working exploit for it. So what you're describing then is ways of obfuscating that binary so that rather than take hours, it actually may now take days or weeks, and they're starting from scratch each time. So I suppose it's that idea of planning that release cycle or just that change cycle of the app to be just under the time that that attacker has to invest in understanding what's going on or pulling out some type of, some interesting or useful functionality to them that they can exploit.
Yeah, we've certainly worked with customers before who've done exactly that. There are some industries where the hacking community is super motivated, and yeah, we've been able to defeat them just by doing regular updates. A very simple thing. Just rebuild, republish, and you set the attacker back to square one. It's a very economic way to combat that kind of activity.
Even if there isn't necessarily an update in the app potentially, right? I mean, literally just kind of do a rebuild and relaunch by itself, because I would imagine there's randomness built into the offering that allows you, even if you didn't make an actual change to the app, just by rebuilding it, it forces a new version of that app and therefore kind of starts the attacker game all over again.
Yeah, potentially. That, even if you didn't want to make a change for an app, we could certainly enable someone to have that kind of protection, change every time they published.
I'm curious, what's your take on? And I there's a few reasonable answers. I'm just sort of curious to hear what you have to say. White hats, pen testers, either inside or maybe people working on bug bounties. How do you think the obfuscation plays with what those guys are trying to do with good intent?
Yeah, no, I think it's all connected, and I think one of the things that we tend to do with those sorts of programs like pen testing or security testing or any of these sorts of things is to look for mistakes, to make sure we haven't done the foolish thing, the thing that everybody knows how to exploit already. But the point of view that we've taken at Ardetto for a long time is we want your app to run as intended, even if the environment you're in has been exploited, even in the presence of someone trying to go after it. So I think they kind of overlay each other, right? You want to do the one thing. You want to do all the testing. You want to make sure your design is secure. You want to run the static code analyzers, and you want to have the pen testers go at it to make sure you haven't made a mistake. But even if you haven't made a mistake, even if you've done absolutely everything correctly, that doesn't protect you from somebody who can take your code, load it in an emulator, use a hooking framework, use a dynamic analysis tool to figure out what it's doing and figure out how to manipulate it. Finally, even things like being able to a hacker being able to manipulate data in memory, which is entirely possible in some of these frameworks and systems. You can't protect against that. Sort of in the design floor, you need to be able to protect that out in the wild while the app is actually running, and that's where our obfuscation and code protections technologies help.
Yeah, that's a good point about having that confidence that the app is actually going to work as intended, even if it is in an environment that is not even necessarily hostile, but an environment that is compromised or changed for some reason. For example, a rooted device, because none of this is predicated on the idea that rooting your Android device is a bad thing. But from for example, a gaming perspective or a fintech perspective, you'd want to ensure that that is not leading to unfair advantages on cheating in the gaming world, for example, if it's based on location data, or in a financial space, that device or the app on that device, if it does detect presence of a debugger maybe, or presence of something else, I'll use the technical term wonky in its environment, then maybe that's additional fraud signal that says we're actually going to make different decisions based on what the app sees, elevate and say, maybe we don't want to accept payments right now, or maybe we want to just flag these purchases or flag this activity at a higher level and introduce something from reCAPTCHA to have a bit of a tie back to our previous segment, or some other type of decision to make on that device. So I think that's another thing that this kind of speaks to is how to just build information about what's around the particular app in a dynamic environment, as you were pointing out.
Yeah, and you make a really good point. We've certainly worked with app developers before, app development houses, who are interested to know whether a device is rooted or jailbroken. But in the end, they want their user base to be happy, right? They don't want to alienate their users, and if their users are rooting their device, the app developer isn't going to be able to stop them, or isn't going to want to stop them. They're not going to want to have that fight. What we provide is the app developer with that confidence that even if someone has rooted their device or installed a hooking framework or done any of those things, the app will run as intended. And this becomes, especially important when you're dealing with, as you say, areas that are quite sensitive. If you're talking about a healthcare app or a payments and banking app or something like that. In healthcare in particular, you want any mobile app that's controlling an insulin pump to run absolutely as intended all the time, because human outcomes are on the line. So I think that's where, that's our attitude toward software protection, that, users will do things, mobile devices, will potentially have malware installed on them. You can't necessarily control everything that your user base will do, but you really want to be sure that your app runs as intended.
And part of that starts to also bring a little bit of the idea from like that developer perspective of what's the cost to me, not perhaps so much as how do I just transform my app to make it hardened in this manner, but does that have, because you mentioned, for example, I'm going to use all my technical terms today, messing with the control flow or messing with the data flow. But do those start to then introduce overhead or latency issues, or are those, what does that start to expose as areas of concern just for a well-functioning and efficiently functioning app?
Yeah, no, that's dead on. If you're going to alter the code a little bit, you tend to add instructions. You tend to make it less optimal than the compiler might be able to do. One of the things that we've invested heavily on at Erdeto is a machine learning model that we use in our backend system that takes into account both performance models and security models that we've developed over time, and does a really good job of recognizing stuff that is security sensitive and stuff that it's better off left alone. Nobody wants their UI slowed down, and nobody really needs their UI secure. That's not the interesting part of the app. So our approach has been, there is going to be a slight overhead for applying security. You want to be sure you're doing it at exactly the right place, and not messing with the other stuff that might impact your user experience.
I want to go loop back to actually something that John was mentioning before too, talking about bug bounty, pen testing. Just shifting to the angle of actual just doing reverse engineering in general, and there could be looking at just random apps on an app store, or for example, malware that's been uploaded to an app store, or even if a company has had their own app wrapped in malware or adware. What are some good tools, resources that you like to always push people towards or direct people towards, just in terms of learning some basics of these reverse engineering techniques, so they can understand then what does it mean to harden one of these apps?
Yeah, sure. Well, if they want, they can look at some of my Clockwork 8 videos. I think I have a couple up there now, but one on static analysis and one on dynamic analysis that people can look at. There are certainly, well-known commercial tools for analysis, things like, IDA Pro or IDA Pro, depending on how you pronounce it, or Ghidra. There are tools tools like Frida that people can use for dynamic instrumentation. I don't know that I could necessarily identify anything offhand, but there's certainly a lot of material out there on the web. You can always start with my videos. They're a fun place to start.
No, those are good.
Yeah. And Catherine, obviously, as we've seen this DevSecOps movement, right? You talk about testing being half of the battle, right? But we do see some friction and some slowdown with the development teams, with the different DevOps teams when it comes to security testing. How does obfuscation fit into this, adding security without adding a bunch of friction into the model? Because we see it in various places as we move through these new agile environments.
Love this question. This sounds like a nice segue, because I was hoping to do a little demo. Would this be an okay time for me to do my demo?
Sounds great.
Sure. Yeah. Okay. I see if I have authority here to share my screen. This looks like the right thing. Let me know if you're able to see my Erdeto web portal here.
Got it.
Great. So this is trusted software. I'm going to show you how it works. And this is going to be just a really quick demo. This is our web portal. Suppose you've built an app. You've already built it. You've done it exactly the way you always build it. It's ready to go, ready to submit to the App Store. You haven't changed a line of code. You haven't done anything differently than your normal routine. You can just take it, select it, upload it to our service, tell it to protect. And you can see here that there's an upload in progress. In a second, you're going to see the new app appear in my job view, and you'll be able to see that it's progressing and protecting it. And that's it. In a minute, it'll be done. You can download it. You can submit it to the App Store. There's very, very little change to your current build process. And of course, if you wanted to make this as part of your CI/CD process, there's instructions on how to hook it in using machine-to-machine authentication. Really, in the end, it's just a tiny little step at the end of what the process you're already familiar with. If anybody is interested in a more detailed demo and some more information about what's actually happening and what decisions are being made in the back end there, they should reach out for a demo, and we'll be happy to talk about it more. But I think that's all I'm going to share for today.
That's great. I mean, you want to talk about frictionless. You just made it really easy. It's like, oh, take this file, drop it here. Oh yeah, here's your new file. Post that one to the mobile store. So I you can pay me the $20 later. I didn't know that I was setting you up so perfectly.
Yeah, no, that's great. And this is exactly the model, we've really worked with. We've been doing security for a long time, and everything is leading towards this model. How do we make it easy for web developers who are really experts in their domain, mobile developers who are really experts in their domain? They know what they're doing. They know how to make excellent user experiences. They know how to add valuable features for the customers, but they don't want to spend a lot of time worrying about security and staying on top of security threats and staying on top of trends. So, our philosophy going into this product is, how do we take that off their shoulders and make it easy for them to do the things that they're expert at?
Yeah, and it's definitely hard to argue with the simplicity of drag and drop and then just wait for it to finish. It was also great to see that the API hooks in there too, so that it can be just a fully automated experience, as well as one and the reason that's highlighting to me is that it's always nice to not take devs out of their familiar workflows and not force them into the security tools workflows, but bring that security tool into where they're already doing their work.
Yeah, this is really important. I think the drag and drop really makes a good, a show floor demo. It's good for the managers and the executives, but anybody who's serious about development knows automation is how you prevent errors. It's how you have traceability. It's how you have repeatability. So that's really important to us, and making sure we're enabling people to hook into their CI/CD systems has been something we've been thinking about from day one.
That's great.
Absolutely. And I think too that also is going to kind of reinforce. I'm just going back a little bit to the idea of protecting the app, and what are sort of those metrics of success. Say, is security working? In the previous segment, John was talking a little bit about fraud and account takeover. So those are different. Those are ways of just saying, is our account takeover number going up or is it going down because we've introduced reCAPTCHA or other bot countermeasures. Same with fraud. We could watch fraud going up or down, hopefully correlated with introducing tools. And in this case, we have something else that I think is still pretty quantifiable that comes into that just was demonstrated in that demo, is that this is easy to adapt, easy to deploy. And your point too is that with the entropy that it introduces, it can be different every time. So our new metric now is that if it's taking 4 weeks for John over there to reverse engineer the app, and we just release on a 3-week cycle, then we're ahead of the game here. We're ahead of the curve. So it's not the idea that this solves everything for the long term. It's just fighting that ongoing escalation of attacker costs.
Yeah, that's right. That's right. It's a little bit difficult to measure, the strength of your security unless you have an active hacker community, as we've talked about before. And then the real measure is, do they give up? Do they go away? Do they seek elsewhere?
No, absolutely.
Interesting thought there. Sorry, I know we're wrapping up, but Mike just made me think of something. What we've seen is a pattern between iOS and Android devices. iOS users tend to be a lot more updated, a lot more current, right, with both iOS itself as well as the apps that they're running on the device. So this idea you have of, or not idea, practice you have of being able to refuzz the app, I'll say, to continue with this technical trend we have here today, to be able to re-obfuscate the app every few weeks. Does that have better efficacy for iOS apps versus Android?
I don't think it makes a difference. I mean, I of course would recommend that people keep their OSs updated, please. But in terms of how the efficacy of obfuscation or code protection on iOS or Android, no, I wouldn't say there was a difference. It's just that that insurance that your app will be protected from the evil intentions of people who might be wishing to use it.
That's interesting, because Android apps tend to. I mean, you've said a few things here today. Third-party app stores, which is more of an Android thing. People rooting devices, I think, is much more of an Android thing nowadays than iOS. So it seems like a lot of your protection really probably is focused more towards Android than iOS, but you think it's still sort of par.
Yeah, I do. Okay. I think people, who are building iOS applications, and a lot of people choose the iOS platform because they think it's more secure. But in many cases, there are also people who are super concerned about security. Like again, someone writing a clinician app that's going to be used in hospitals, they may choose iOS as a platform, but they still really, really care that nothing goes wrong, that the app always operates as intended, and for that reason, they're going to look at code protections on iOS as well as Android.
No, as I'm curious too. So there's you might notice a trend here. I asked John to not quite look 70 years in the future in the last segment about what's coming up. But is there anything else coming up over the next couple of weeks or months that you wanted to highlight, either on some reverse engineering, some more cloakware Kate videos, or something about the static and dynamic analysis type of countermeasures that's of interest to you, or that you has really been highlighting?
No, you're putting me on the spot a little bit. Certainly, the marketing team wants me to do more Cloakware Kate videos, and I'm running out of time. So there's none of those coming. Though I think anybody who's interested will be very interested in a white paper that Erdetto is about to publish on application security. So they can certainly reach out and take a look at that if they want to see what we have to say on that subject.
Cool. Well, we'll definitely keep an eye out for that white paper. We'll definitely have to say thank you for taking the time to chat with us here, rather than going out and doing another one of your Cloakware Kate videos. Thank you.
Thank you.
I want to just say thanks again, Catherine, for joining us. I want to thank my co-hosts, Matt and John, as well. Thank all of you listeners. If you do want to learn more about Erdetto, visit securityweekly.com/Erdetto. And just want to say one more thank you for joining us. We'll see you again next week on Application Security Weekly.